Welcome to the next session, Optical Fiber Communication. Today we will discuss in brief about fiber cables, different types of fiber cables. So an optical fiber cable is a type of cable that has a number of optical fibers bundled together, which are normally covered in their individual protective plastic covers. As we had seen in like buffer coating, right, in our last session, we have discussed providing plastic protection or buffer coating very soon after the fiber drawing. So individually they will be protected. Optical cables are used to transfer digital data signals in the form of light up to a distance of hundreds of miles with higher flow rates than those achievable by electrical communication cables. As you know, all optical fibers use a core of hair-like transparent silicon covered with less refractory index cladding, unlike light used to its So types of fiber cables. So based on where we are going to use this cable, as you know, we are using fiber cable for multiple areas, like it can be used either in urban area or indoor area. And again, they are based on how the cable is packed inside or how the fiber is packed inside the cable. They again classify optical fiber into loose tube cable and tight diaphragm cable, and based on the number of fibers present in a cable, we have another classification of type, that is driven cable. So purely based on inner application or outer application, firstly we classify the optical fiber into two, that is outer cable and indoor. So as you know, in the indoor cables, as the environmental pressure or environmental behavior, it's optimal that we doesn't require any other extra or additional protection to these fibers. So we can use these fibers as such with minimum protection. So when compared to this optical fiber which is in outer application, you can see a wide relative variation. Like a single fiber is initially coated by some buffer coating. It is having some colors. We will discuss the types of colors, why there is some colors all in our coming sessions. So approximately in a single tube, you can see the tube like that, yellow colored, green colored, blue colored, etc. Right? So inside each tube, there can be a maximum of 12 fibers. It is a limit. A maximum of 12 fibers can be included in a single tube. Okay. So in a single tube, there will be 12 fibers. Again, you can see there are some different colors in tubes like yellow, blue, green. So in a single cable, there can be large number of fibers. So this number of fibers will be arranged as a pack of 12. So these tubes or these loose tubes are arranged in a twisted manner, usually in a twisted manner. It will be arranged around a central strengthening member. You can see a white material over which these tubes are surrounded. Actually, the purpose of that central member is to give some mechanical strength against the bending. See, in our last session, we had discussed bending losses and all, right? So this internal strengthening member will resist bending after a limit. So after this or around or outside this tubes, you can see there is a white coating. It's an additional coating for providing protection. Over that, you can see a steel armoring. The steel coating is provided. Usually this coating is provided for cables that are provided for direct bury. See, suppose, hope you have seen laying a cable under the ground. It can be directly laid or it can be laid inside a duct. If you are providing a duct, then we can we can have an extra or additional protection from pests like rats and all. See, if you are not having any duct, see, usually in the case of normal electrical wire, copper wires, you may be able to see ducts inside the duct, some ducts inside the duct, the cables or fiber that copper will be laid. So similar to that, this optical fiber can also be laid inside a duct. So in such cases, we can avoid. See, if we are drawing an optical fiber or fiber cable inside a duct, then we can avoid this greenish thing. That is the armoring. But this armoring is very important when we are directly burying the cable under the ground. Then this cable will be subjected to many pest actions like rat bite and all. Okay. Now here here you can see another structure, corrugated structure. See, actually, if this cable is used for aerial purpose, see, in the outside lane, it can be either buried underground or it can be drawn through poles or posts. So in such cases, this fiber will be hanging in the post. So this is termed as a self-strengthening member. See, in electrical lines, you can see we are providing some stay wires, right? It is for providing some self-strength so that it will be intact. So based on the area where you are going to use the fiber cable, there will be some variations in the cable construction. So as I had discussed just before, if you are going to draw the cable inside a duct, then you can avoid this armoring. And also you can avoid this self-strengthening member. Now again, if you're going to use it in the outdoor application where it is supposed to be laid aerially, then this self-strengthening member is very, very essential. Now types of outdoor fiber cables: simplex cable, duplex cable, duct cable, direct buried cable, aerial cable, and reverse. See, this we have already discussed. Simplex, in the sense, you know what is simplex communication and duplex communication and all. There will be, with the simplex cable, there will be only single fiber, while in duplex cable, there will be a minimum of two fibers. And in duct cable, as we had discussed this before, what will be the main variation? In duct cable, we won't be having any extra armoring or corrugated steel armoring. But in the case of direct buried cable, there will be extra strengthening member beyond this black covering, beyond that black covering that you can see. And aerial cable we have discussed, premise cable. So this is basically a general structure of an optical fiber cable. So you can see this is a central strengthening member over which we are arranging various tubes. Inside each tube, there can be a maximum of 12 fibers. It may vary based on number of fibers. In the presence of number of fibers inside the tube, each tube will vary based on the number of fibers drawing through that single cable. So there will be a central strengthening member which protects the cable from bending losses. Then over which we are arranging the various tubes. So these tubes are again will be again covered by what? Single side water swell level tape. You can see this single side. You can see that, right? Single side water swell level tape. Then again, another protective mechanism to prevent the entrance of water. Then inside this, you can see yarn. It is fiber-like material which also provides some strength to this loose tubes. These tubes. Then maybe it will be put with some powder particles or flooding jelly which will absorb water molecules. This inside the tube also there will be some jelly type materials or powder materials in order to prevent the entry of water. Above which we will be having some multiple plastic coverings. Okay, so these multiple plastic coverings can be either LDPE or HDPE, depending on the time where we are going to use this fiber cable. So HDPE is nothing but high density polyethylene outer sheet. Okay, then here it is written as this tube is written as loose tube type. So usually when we discuss the outdoor cables, since as you can see there are many or multiple protective mechanisms, usually this tube will be loose tube. That is, inside the tube, the fiber will be loosely packed. That you will see in detail in our coming sessions. But if this cable is intended for indoor applications, then this will be tightly buffered based on the application region. Like I had said before, whether it is directly used, directly exposed to the air or not. If it is directly exposed to the air means what? If it is directly exposed to the outer, it requires more and more additional protections. So based on the protection mechanism we need, there will be slight variations in the constructions. Like we will see in detail in our class.